Okay. So I'm gonna multiply this out. I asked you guys to spend a couple minutes trying it without me, but now I'll talk through it. If you don't want to hear what I say, you can just kind of wait and look at it at the end, but we did first row and first column, that's all yellow. Now I'm gonna do first row, second column. And that's gonna get me the spot that's in the first row, second column. So 2 times -1 is -2. -1 times 3 is plus -3, and then 3 times 4 is plus 12. I'll simplify that in a moment. Okay. Now, in order to get the first row, last column, I'm going to do first row, last column. 2 times 2 is going to be 4, plus -1 times -1 is 1, plus 3 times 0 is 0. Okay. Now I'm going to do second row, first column. Second row, first column is going to go in the second row on the first column of the new one. 5 times 1 is 5. Plus 1 times 0 is 1, plus 4 times 1 is 4. Am I moving too fast, or is everyone okay so far? Okay. Now we're gonna do second row, second column. Second row, second column goes here. 5 times -1 is -5. Plus 1 times 3 is 3. Plus 4 times 4 is 16. The last one we're going to do is second row, last column. Second row, last column, second row, last column is that last spot. 5 times 2 is 10, plus 1 times -1 is -1, plus 4 times 0 is 0. And again, I told you I like to do this step, which I know that some of us may not want to do that step all the way up, but I like to do that, so now I can simplify and know that I did it correctly. So I'm going to go simplify. Megan?
Shouldn't the one in range be 5 plus 0?
Yeah.
Is it? Okay. So, and that was just one mistake, and that would mess up my whole thing, so just be careful, that's why I write it out like that. The -2 plus -3 plus 12 is gonna be 7. 4 plus 1 plus 0 is 5. 5 plus 0 plus 4 is 9. -5 plus 3 plus 16 is 14. And then 10 plus -1 is 9. I'm not gonna coordinate all my colors, but you see where all the colors come from and where all the pieces go. I notice a pattern here. I don't know if that pattern necessarily means anything, so don't let that get too in your head, like, oh, it's the first and last one are always the same, and the middle ones always do this. I think that's just happens to be how the numbers work out. Okay. All right, next we want to do A times C. Does anyone have any questions on DC before I get into AC? Okay, so if I go to write AC, what are my dimensions for A?
2 by 2,
What are my dimensions for C?
3 by 2.
Can I multiply those together? No, I'm not even gonna write it down. I will, just so that I don't forget when I come back later and be like, why did I just not do that problem? We didn't just not do it, you just can't do it, it's not possible, no. The middle ones should match, and so I have a 2 in my column and a 3 in my rows. Those do not match, it's not possible, you cannot multiply them. So see, we've only done like 5 problems and we've already written no twice. So no is an okay, it's an acceptable answer here in this part of our chapter. Okay. Now, the next part, it's another multiplying, but it has this capital T here. We're actually going to go back to the definitions. I skipped to the last 2 definitions just because I felt like it was a lot of information all at once. So I want to go look at those last 2 definitions. And one of them is going to tell us how to do this capital T. All right, so the first one's transpose and the second one is trace. Transpose is actually what that capital T means. It means that we are going to flip the matrix across the diagonal. We're going to flip the matrix across the diagonal. The numbers on the diagonal stay the same, but the other numbers switch spots, they flip. Essentially what happens is we switch our rows and columns. So whatever was like my first row changes to become my first column. Whatever is my second row changes to become my second column. So that's what happens when we flip across the diagonal. Okay. We're gonna do that momentarily. The last one, trace, and I don't know if we do this a lot. Trace means that we're gonna do it the sum of the elements along the diagonal. Sum of the elements. If I could spell, that'd be great. Along the diagonal. Now you can only do this in squares though. Only square matrices.
Can you transpose in the?
Ooh, great question. I believe so, but
But when did it change from like 3 to 2? Would it change?
It would.
2 to 3?
mhm. Let me get back to you. I did not come prepared for that. I did not write only in squares on transpose, so that makes me believe that it could be done in other matrices, but we'll double check tomorrow, okay? We are about to go transpose in a square matrix though, so let's go jump to that. So once you have these two definitions, go back to where we just left off. And that capital T that we just saw, that means that we are gonna transpose. Basically what that means, I'm gonna give us a very basic original matrix, and I'm gonna use this a few more times in a few more minutes. The original matrix is gonna go A, B, C, D. When we do the transpose, my A, B is the first row, and that changes to my first column. So I'm gonna go A on top and then B underneath it. And then instead of C, D being my second row, C, D is gonna be my second column. So if you notice, my diagonal, the AD stays the same. And then B and C just kind of flip on either side of it. So that being said, my A matrix is 1, -2, 3, 5. When I do the transpose of that, what does it become?
1, 3, negative.
Good, 1, 3, -2, 5. See how my -2 and 3 switch places? The 1 and the 5 stayed the exact same. That's not all at once from us, though. It doesn't just want the transpose of A. We also need to multiply that new matrix by B. So now I want to write B next to that and multiply those two together. I got my A transpose and then times B. I gotta go figure out what B is, so give me a second. 6, 3, 0, -4. All right, this is multiplying, which we've done. I'm gonna be quiet and I want you to try and multiply without me, okay? I don't need to check, but if you wanted to check, it's a 2 by 2 times a 2 by 2. So my answer, so we can multiply those together, and my answer is going to be another 2 by 2. All right, I'm gonna put my work on the board, but I'm gonna be quiet, so you try to work it out on your own. All right, I've got my work, I've got my colors, I've got my final answer up on the board. Go ahead and give it a check when you have it. Make sure I did it correctly too. Did everyone get the same answer I did? Okay. All right, you guys ready for the next two? Okay, now this one also has something kind of funny, right? It says DETA and then DETB. We haven't talked about DET yet, have we? DET is another word that probably should have been in our definitions. It's the word determinant. The determinant of a matrix. Now, determinants can only be in square matrices. And we're gonna do it by hand for 2x2s. And then anything bigger, we're gonna put in the calculator. I think a 3x3 by hand is pretty easy. I may show you that, but I'm not gonna necessarily test you on that eventually. Okay, so determinant, just like we did before, I'm gonna give you your original matrix, so we're gonna go A, B, C, D again. We get the determinant, which is a real number, it's a whole number, it's not a matrix, it's a number. We get the determinant by doing A times D minus B times C. A times D minus B times C. So I multiply the two along the diagonal and then minus from the other two diagonal from each other. A times D minus B times C. And that should give you one number that pops out, okay? We're gonna use that one number in a minute, so we gotta practice just finding that one number first. Okay, shall we do it? All right, A is 1, -2, 3, 5. I believe I remembered that, right? Yep, okay. So my determinant is that we're gonna do 1 times 5 minus -2 times 3. Are you guys okay with that? All right, 1 times 5 is 5. Minus -2 times 3 is -6. What's -5 or 5 minus -6? +11. See how that's just one number? It's not a matrix, it's nothing crazy, it's just one number. When you're done with letter A, go do letter B. Do determinant of B. I'm working it out now if you want to watch. All right, I've got my answer for determinant of B. Did you guys get what I got? Awesome. That wasn't too bad, was it? Okay. If you flip your paper, we're actually going to skip a couple things. We're going to skip determinant of C because that's bigger than a 2x2, right? So if you remember determinant, we're only going to do 2x2 by hand for now. So if I feel like it tomorrow, I'll show you this. If not, we'll definitely do it in the calculator. So we're not going to do any calculator stuff today. We're just going to do solely hand by hand. Now, letter D, the next number says, let's do the determinant of letter D. Can we do the determinant of letter D? Why not, Ryan? Not a square, it's gotta be a square. So we can do this letter K, determinant of D is just no, there is none. It can only be a square. And then if you look at number 3, it's another 3x3. I'm gonna save that for tomorrow, okay? However, I've been kind of stair-stepping us up to this next skill that I want to do at least 1 or 2 of before it's time to go. Number 4 says using the matrices in number 2, so using A, B, C, D that we have been using, we want to do A to the -1. You guys remember what that -1 means?
First,
Inverse, very good. Inverse, so we're gonna learn about, or talk about inverse, so I'm gonna again do a little bit of notes off to the side, inverse. We know inverse operations are like addition and subtraction, multiplication, division, all that fun stuff. When we do inverse of a matrix, we need the determinant, which is why I just taught you determinant, okay? And again, we are only gonna do, we're gonna do by hand, 2 by 2s again. And then just like I said, determinants just needs to only be squares too, because if we can't find the determinant of something, we can't find the inverse of it. So just like last time, let me give us an original matrix, A, B, C, D. The inverse is when we do 1 over the determinant times a scrambled matrix. Now, the scrambling is the important part, okay? So I'm gonna switch, when I do the inverses, I'm gonna switch A and D. They're gonna switch spots. I'm gonna start with D and I'm gonna end with A. B and C are gonna stay in the same spot, but they're gonna go opposite signs. So if they were positive, they become negative. If they were negative, they become positive. I know I just wrote C, but I changed it to a B, sorry. I couldn't talk and write at the same time. B and C stay in the same spot. They just changed their sign. So if it was positive, it's negative. If it's negative, it becomes positive. And then we're gonna distribute that 1 times that determinant by everything inside, okay? So I wanna get through inverse of A and B, and then I think we're good for today. Now, so if we're gonna do inverse of A, we gotta remember that A was, I think it's 1, -2, 3, 5, am I still right on that? In order to do the inverse of that, we need to know the determinant. Did we just find the determinant though? What was it? 11, good. So I'm not gonna make us resolve it out, but I can go back up here and be like, oh, I already found the determinant, it's 11, so I'm gonna use that. I'm gonna say 1 over 11, and now I need to scramble my matrix. A and D switch, so 5 and 1 switch. And then -2 and 3 stay in their places, but they change signs. So -2 becomes +2, +3 becomes -3. And I know that we want decimals a lot. I just want you to distribute this through and leave it as a fraction. Multiply each of these by 1 over 11, which I actually think is easy because there's no simplifying to be done. It's 5 over 11, 2 over 11, -3 over 11, 1 over 11. That's as good as that gets. Good as that gets.
that's our final answer.
And that's your final answer. Now, we're gonna eventually use the inverse more than that, but that's all I'm asking for right now.
You go back to the notes, you know the notes.
This guy right here. All right, if you think you got that, I want you to try the inverse for matrix B. And the inverse for matrix B.
Yep.
You good, Michael?
Yeah.
I'm gonna do it, but I want you to try it on your own, so you can watch me if you need help.
If we can, break it down, could we?
Yes, if you can simplify your fractions, yeah, please do. Now, just like in doing the inverse of A, we didn't have to actually find the determinant because we had found it a minute ago. That's just us working smarter, not harder. There are gonna be times that you will have to find the determinant and then use it for the inverse. I knew my inverse here, or my determinant was -24, so I did 1 over -24. And then I switch A and D, so -4 and 6 switch. 3 becomes negative, 0 is just 0, so it can't become positive or negative, it's good as it is, and then I distribute that through. So I got 1 over 6, 1 over 8, 0, and then -1 over 4. Cool. All right. I wanted to do a full day, no calculator. Tomorrow, we're gonna add some calculators, finish this section. We were almost done. I just didn't want to, I didn't want to speed us too far through this. And then we'll start 7.3. Anybody have any questions? So technically, I haven't assigned any homework yet because we haven't technically finished, but you have the ability to start on those.